board. All right, so global is when you're looking at the entire picture, or absolute. Where's the highest or lowest point for maximums or minimums? The local is in its own little neighborhood. So here's what they say. The relative max or min is a point on the function that's higher or lower than all the points immediately surrounding it. So we call it in the neighborhood. So are you a high point or low point in the neighborhood? If you are, then you are considered a relative maximum or minimum. And when you're talking maximums or minimums, you're talking what the y values are, because you're looking at how tall it is or how small it is. We're going to be looking tomorrow at a roller coaster example that kind of explains it pretty well. So finding a max or min means finding the y value of the point. The x value helps you with the location of the point, but it's not considered to be the maximum or minimum. If you're thinking again like a roller coaster, the maximum point you're at is like the hill, and the minimum point you're at would be like the valley when you're turning around. Cohort B's, you are welcome to leave if you would like to. However, numbers 1 through 7 of section 3.2 that we're covering right now are due by the end of the day today. So if you choose to leave, that's fine. But realize that your deadline for section 3.2, numbers 1 through 7, is today, and I will see you tomorrow. So if you choose to leave, that's cool. All right, so out in my margin, one of the things that you're looking at, we're kind of going to ignore infinities, but we'll talk about that a little bit more when we get into the examples. So the first thing that I put in my margin was for absolute maximums or minimums, is it the highest or lowest point overall? When you're looking at the entire picture, are you the highest or are you the lowest? And that's your absolute max or min. And so for relative max or min, again in my margin, I have a relative max or min, is it the highest or lowest point in its neighborhood? In its little area, are you a high point or low point? Are you a hill or valley in your little neighborhood? All right, we'll try some examples and then I'll show you the last bullet point I have in my margin there. So he graphed this beastly function over here of 0.05x to the 6th. This guy here, he graphed. And he got this picture. This is your picture for the graph. And so he went through and he talked about what these coordinates were. So he used negative 2.6, negative 41.3. This right here was 0, 1. And this point here was 4.2, negative 57.7. Now there are key points. When you're looking at maximums or minimums, right, extrema, you're looking at where the high points and the low points are. So you want to know what those coordinates are so you can answer the questions. So find the coordinate points of the extrema for the function and classify the type. Let's go absolute first. So if I'm looking at absolute, is there an absolutely high point on this graph? And so you're looking at the whole picture and you can see that right here, that's kind of a high point in the middle, right? That's like a hill. But the problem is that the highest point overall? Are there points higher than him? Yeah. Yeah, because he goes to infinity, right? So there is no absolute maximum in this case because there are points that are higher than this guy. So I do have high points that go up to positive infinity. You can't tell me what infinity is. You can't define it. So therefore you can't have a maximum point because it keeps changing its infinity, keep getting bigger and bigger and bigger. So there's no absolute maximum. But let's go to absolute minimum. If I'm looking at this picture, is there a lowest point overall in the whole picture where it doesn't go any lower? Yeah. Yeah, over here, right? This guy? He's my lowest of all. Nobody gets lower than him. He's the low guy. So I have an absolute minimum at that coordinate, 4.2, negative 57.7. There's my absolute story. Now if I'm talking local, if I'm talking relative, sometimes called local, then I'm looking at in the neighborhood. Now I can see that this is a valley. He's a valley. If that's a valley, then that's a minimum. In his little neighborhood, he's got a little minimum going on. So I have a local minimum at negative 2.6, negative 41.3. And then I keep looking at the graph, keep going, and I come up to this place. Well, there's a hill. He's a high point in his little neighborhood. He's not a high point overall, but he's a high point in his hood. So he's considered a relative or local maximum at 0, 1. And then I keep going and I get this low point again, and we already talked about him. He's the absolute minimum. Nobody goes lower than him. So he is considered your absolute minimum. Now the question is, think about this for a minute. If you're an absolute minimum, I'll say in this case, are you also a relative minimum? If you're an absolute minimum, can you also be considered to be a relative minimum? If you're the lowest point overall, can you also be considered the lowest point in your hood? Kind of a weird question, right? Yep. But the answer is yeah, you can. Yeah. If anybody that's absolute is also considered relative. Okay. Now wrap your brain around that for a second, because now I'm going to go the other way. Let me go back to this guy. He was a relative max. If he's a relative max, can he also be an absolute max? If you're relative, if you're a high point in your hood, are you the highest point overall? Yeah. You think? No. Didn't we? Yeah, we said no, because we said it was going to be an absolute maximum. There was none because it kept going to infinity. So here's my next bullet point in my margin. After all that, absolutes are considered relative, but relative are not considered absolute. So if you're an absolute max or min, you're also a relative max or min, because in your little hood, you are the highest or lowest point. But the other way doesn't work. It kind of reminds me of back in geometry with our rectangles, squares, and squares, rectangles. Remember that whole dilemma of trying to figure that out? Did you ever talk about that back in the day? Yeah, it's been a while. Yeah. But anyway, with absolutes are considered relative, but relative are not considered absolute. So that's important. All right, then to finish up the rest of what he talked about, he said you've got this is an example where you have an absolute minimum. This is the lowest point overall. But see this dot, because it's included? In his little area there, in his little hood, he's a high point. He's considered a relative max. He's a high point in his hood. He's not the highest point overall, because the highest point overall goes to infinity. But in his little area, if I were to trace this graph, he's going up until I get here. That's a maximum point in his hood. Then he showed you this picture. And he said, same idea, this is still the absolute minimum. Nobody goes lower than him. But I have an open circle here. And if it's an open circle, then I can't make any determination as to whether it's a high point or a low point, because I don't even know what the point is. So there are no relative maximums in this, where when it was a closed circle, that was considered a maximum in its hood. And then I've got this third picture that adds a whole nother dilemma. I have this is the relative minimum. Now, this one, notice it changed. In the other two pictures, it was considered the absolute minimum. But this one now is considered a relative because do I have lower points than it? And in the other two graphs, ain't nobody got lower than him. But in this picture, this guy continues on to negative infinity. That means that there are lower y values other than him. He's not lowest overall. And so because of that, he now changes from being an absolute minimum to a relative minimum. This circle is still open, so it's nothing. And now I'm tracing over to the next part of the graph, and this guy's a high point in his hood. He's not the highest point overall because they go to infinity. And so he is a relative max. So things change up when infinity gets involved. So you're when you're figuring out relatives, you're ignoring infinity. But when you're looking at overall, you want to include infinity. So it's absolutes are including infinity where relatives are not. Okie doke. Then he went into, this is the last one he talked about. And he took a while to graph this thing. We're going to use Desmos. Desmos is going to be our friend. And so just a rough sketch of the, because he did this whole thing with the window when you watched it. Now if you're using Desmos, you can just scan in and scan out. So you can change it so the window can be friendly. So you don't have to worry about the whole thing he described as a friendly window. Don't worry about it. You got Desmos. So you graph this function. Now let me go down and show you my graph first. So here's my graph. And this is what you got when you put, either you put it in Desmos or whether you took his picture. you've got this thing going on, and there's a couple coordinates that are going to be important to you. The first coordinate is this one here at 4, 0. So you've got a coordinate here that's at 4, 0. Then you've got this high point over here, and that high point's at 3.14, comma 5.04. It's kind of hard to see on your screen, but this guy here is 3.14, 5.04. That's the high point here. Then you're tracing along your graph, and now you're at a low point again, and the low point is at 0.064, 0.996, 0.064, and 0.996. And then it goes for the rest of the graph up to infinity on the other side there. All right, so 3 coordinates that are going to be important to us. We have them labeled. And the first question wants to know, what's the domain? Well, we just did a whole big section on domains, right? You can see from the picture, if I were to read this from left to right, it's easier to find domain when you're looking at the picture. It starts on the left at negative infinity, and it stops x values, furthest point on the left to furthest point on the right, it stops at 4. And so it's going to be negative infinity to 4 with a bracket at 4. That's the same thing as if I looked at the equation from back when we were just doing these. We know that 4 minus x has to stay positive. And so I know that when I solve that out, x has to be less than or equal to 4. Now we just said you could also call that negative infinity to 4 with a bracket from looking at the graph. So I'll put a little or in here. So looking at this, let me see if I can put this so you can see the graph too. Yeah, good. Okay. So the next question was, where are the vertical asymptotes? And you look at it, it doesn't have any vertical asymptotes. Vertical asymptotes come from the denominator equaling 0 and nothing canceling out. All right, from back in section 3.1. Does it have holes? No, you had nothing to factor. There's nothing that cancels out. You don't have a denominator. Again, doesn't have any of that stuff. So there's your holes. There are none. Does it have an absolute min? So go back to the picture. Overall, is there a lowest point that ain't nobody getting lower than him? And you do, right over here. This is the lowest it goes, is this point that's at 4, 0. It didn't ask you about an absolute max. Oh, well, it did in the same question, absolute max. Does it have a highest point overall other than infinity? If you're looking at the whole graph, you kind of have a high point here. This one would be the place of question, right? That's your high point of maximum. Are there any points that go higher than that point? So look at the whole picture. Over here, see these guys keep going higher and higher? So because this n gets higher point, this y value here, this coordinate, is bigger than this one. And if I keep going up the graph, this one's bigger than this one. So this is a maximum, but it's only a maximum in his little hood. He's not a maximum overall, because there's other points higher than him. So there are no absolute maxes. But again, he is a maximum in his hood. So he would be considered a local maximum at 3.14 and 5.04. And technically, if you remember from the front part, it's really just the y value that's recorded. So that's why you see it here as 5.04. That's the highest point it gets to in that little area, 5.04. And then it has a local minimum right here. That's a low point, but it's not the lowest point. He's still a low point. And so that is at 0.064, 0.996. So there's your local maximum. And then they want, where is it increasing, where is it decreasing? So if I go back to what we learned in Unit 2, the first thing, if I'm on this roller coaster, the first thing it does is goes down until I get here. So it's decreasing from negative infinity until I get to 0.064, the x value. These are those ones where you're looking at the y's, but you write the x's. So negative infinity to 0.064, then it increases. I go up the roller coaster between 0.064 and 3.14. That's increasing. And then I'm decreasing the rest of the way from 3.14 down to 4. And so there's your increasing, decreasing boxes. The left-hand behavior is the same thing as saying if I go really far to the left, What are the y values doing? If I keep going left, what are my y's doing? They're getting bigger and bigger and bigger. They're going to infinity. And if I continue to the right, it stops. It just takes a dead stop. And so that means that there is no end behavior. It just stops there, so it doesn't exist. It doesn't keep going to the right, it stops. All right, that takes you through what the video talked about. Let's now go to our problems that we're going to do. Find them here. All right, so these are the practice problems. These are numbered kind of funny, just so you know. This is number 1. They're numbered like in the middle of the page rather than off to the left of the page, because that kind of messed me up. I was like, what are you talking about? What numbers are they? So number 1, number 2, we're going to look at number 3 as our first one that we're going to do together. So number 3 looks like this: x cubed minus 8 over x squared minus 4. And we have to answer all of those same questions based off the graph. Now, lucky for us, they gave us the graph. So I don't have to go to Desmos quite yet. They gave us the picture. And so if I'm looking at this picture, before I even start with all this mess, I think I want to figure out, remember the sections on Extrema, maximums and minimums, I think I want to give coordinates to those places so I can then answer their questions. So I'm looking at it, I can see that this is a low point right here, and that low point is, give it a coordinate, x is 0 and y is 2. And then I also see I kind of have a high point over here on the other part of the graph, and that would be at a coordinate of -4, -6. I'm looking at also at the graph here. What do you think is happening over here at -2, where x equals -2? What do you think is going on there? From previous things we've talked about. Any guesses? You're a quiet bunch. How about a vertical asymptote? Can you see it now that I said it? Right? It's a line that the graph approaches but doesn't cross. You can see it's hugging it from either side. And so you've got this vertical asymptote going on there. So graphically, there's some of the things I'm thinking about. Also, I've got a hole. This is a holy graph. And that hole is happening, I'm going to say that that's at 2, 3. The coordinate 2, 3. Right? X is 2, y would be about 3. And I think there's not much else I can say, so I'm ready to go on and answer the question. So let's see. I have domain as the first thing. Well, domain from the picture is left to right. This guy's in pieces, so I'm probably going to have more than one piece. So I'm coming along. By the way, these go towards infinity, but all of these little, they didn't put the arrows there for some reason. So if I'm reading it from left to right, then I'm reading this piece here. This piece comes from -infinity, and it goes to -2, but will it touch -2? And we say no, because it's an asymptote. So put a little parenthesis with that. All right, then it picks up again. We're not done with domain because that's only talking about this little piece here. There's more to the graph. Then it picks up again on the other side of -2, doesn't touch it, put a parenthesis, and it stops where the open circle is. Well, where's the open circle? The open circle's at 2. Can you touch an open circle? So I'm going to parenthesis that. And then I'm continuing on. Once I get through that circle, then the rest of the graph is fine. I'm smooth sailing the rest of the way from 2 to infinity. And all of that is my domain. All right. So then I'm looking at this picture and I'm like, well, is there an absolute max or an absolute min? So looking at the whole big picture, the entire thing, I might think that this would be a minimum, this would be a place I would consider for an absolute minimum. But then I have to ask myself, are there y values that are lower than that guy somewhere on this graph? Are there y values somewhere else that are lower than 2? And you can see there are y values down here, right? So this guy can't be an absolute minimum. He can't be, because there's other y values that are smaller than him. And the other point that might come up is this guy being an absolute maximum. And so if you're thinking about that being a maximum, because it is a hill, but are there other y values that are taller than him? Are there y values bigger than -6? And there are. Up here, these are y values that would be bigger. So in other words, there's none. There are no absolute maximums or minimums in this picture, because there are other points that are taller or smaller than the ones we would have. But there are relative, because in his little neighborhood, he's a hill. He's king of the hill over here. So I have, he would be a maximum. He would be my relative or local maximums. So you can call it whatever you want, relative or local. Max. And that is the coordinate -4, -6. And then if I keep going over here, this guy is going to be considered a relative minimum. In his little neighborhood, he's a valley. Okay, so over here, he is a minimum, but not overall. So he's relative or local, min. And then you give the coordinates of that, it's 0, 2. And then the rest of this is just kind of review stuff back from Unit 2. Where is it increasing? Where is it decreasing? I find it easiest to just start on the left and just go across and see what it's doing. First thing it's doing is increasing until I get to here. So in my increasing box, it goes from -infinity, and then you do -4, the x value. And then it's decreasing from -4 to -2, decreasing -4 to -2. That's this part here where it goes down. And then I swing over the asymptote, and now I'm up here. I am decreasing again until I get from -2 to 0. So decreasing from -2 to 0. That's this part. And then it's increasing, but it's got a blip. So it's increasing from 0 to the open circle of 2 until I get to the other side of 2, and then it goes increasing to infinity the rest of the way. So 2 to infinity. So there's my increasing, decreasing. And then the last piece is, what's it doing when I go far left, and what's it doing when I go far right? Well, going far left, here I go, tracing left, 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 left. It goes to -infinity. So that's this guy. If I trace it to the right, 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 it keeps getting higher and higher and higher on the right. So he goes to positive infinity. And there you go. You have just answered number 3. I'll stop there for a sec. Questions from anybody? You okay? All right, we're flipping. Want to try one more together? And that would be number 5, because number 5 looks pretty darn ugly. All right, so here's number 5. This time they were not nice to us. They did not give us a picture. So here's where Desmos comes in. So take a second, set up your Desmos. You're going to want to do this at home too. Grab your, switch over to Desmos. And we're going to put this guy in Desmos. I'm going to share my screen with my Desmos as you're grabbing your Desmos. And I want to show you how to put these in, because some of them involve, and you'll see this guy particularly, he involves absolute values and square roots and all sorts of things that we have not looked at in Desmos. All right, the one I want to look at, I'm going to turn this one off, turn this guy on. This is the one that we're trying to get to. All right, so it is my second one. Now, as you're typing this in, I don't like halves. Halves are the same thing as 0.5. It just is easier than typing in 1/2, so 0.5. And then how on earth do you get this square root? Well, if you come down here to the keypad button on the bottom left, you will see that there's a square root button. So you're going to hit the square root and type in 4 minus x. And you're typing it the same way that it appears on your sheet, which is in parentheses. All right, so take a minute. You're typing in 0.5, 1/2, parentheses, square root of 4 minus x. Close those parentheses, just like your sheet shows. And then to get absolute values, you've got an absolute value right here in the same toolbar at the bottom. So you open up the absolute value, and in your absolute value you want 2x minus 4. And then right arrow to get out of your absolute value, this +1 piece. And then hopefully you should have the same picture that I've got here.
Pardon the interruption. This is the last call for staff and students grades 7 through 11 for picture retakes in the auditorium. Once again, last call for staff and students grades 7 through 11 for picture makeups in the auditorium. Thank you.
Okay. Okay. So my hope is that then when you graph it, you've got the same picture I've got going on here, right? We good? So that was a complicated one, but it's good to remember how to do that. I know you guys are pretty familiar with Desmos. So let's take into consideration some of the coordinates that might be important as we answer questions about maximums and minimums. So one of them, if I'm looking at this, I come down here, if I go from left to right, oh here, look, that point is kind of important to me. The coordinate is 2, 1. Toss that on your picture, right? Did you take a second yet and draw it on your paper? Probably not, so let's draw it on our paper. I've got a 2, 1. And my graph comes down, goes through 5, comes down like, I'll show you my paper in a minute. All right, the next point that might be important to us is this high point. Well, the high point is at 3.33 and 2.1, we'll say. 3.33 and 2.1. And you probably want to label them on your graph. And then you get to the end here, and that coordinate is 4, 1. And all you're doing is clicking on Desmos. It's really sweet. You just click on that point and it tells you exactly what the coordinates are. So 4, 1 is my ending place over here. I'm going to take away my Desmos now that you've seen the picture, and I'll go back to my paper. And so we're all on the same spot here. Here's what you got going on. So you've got this coordinate was 2, 1. The high point was 3.33, 2.1. And then this goes 4, 1 as my stopping place. And once you have the picture, now remember this goes on to infinity on the left, and it stops at 4, 1. It just doesn't go anywhere past that. And then I can answer other questions. So question number 1 is, what's the domain? Looking at the picture, if I start on the left, it's happy, 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 all x values until I get to 4, but then it stops. It doesn't have anybody past 4. So it's going to be from negative infinity, my domain, until I get to 4 with a bracket. It stops at 4. Doesn't go anywhere past 4. Left to right, domain. All right, so here's my question. See if you can answer the rest of those, and then we'll see if we match. I'm going to give you a try. Give it a shot. Tell me the absolute max or min. Tell me the local maxes or mins, increasing, decreasing, and what's it doing on the left and the right. So follow through just like we did the other ones. All right, let's see how we match here. You have an absolute minimum. There's actually two of them. They both are at 2-1 or 4-1. Sometimes you'll see it written this way, that the absolute minimum is 1, because it's whatever the y value is, but sometimes it's safest just to leave it as a coordinate. But really the smallest that it goes to, the lowest y value it hits is 1. And so sometimes you'll see it written that way, especially because there's 2 points involved, either 2-1 or 4-1. They're both the low points. It does have a local max, relative max. It's a hill in its little neighborhood here, but there are other y values that get bigger than it, so it's not an absolute. So at 3.33, 2.1, that's your local max. If I'm reading the graph, it decreases from negative infinity to 2, increases from 2 to 3.33, decreases from 3.33 to 4, and there's your increasing, decreasing. End behavior, if I go left, left goes to infinity, right stops at 4, so it doesn't go anywhere else. It doesn't go to infinity, so it doesn't exist, that right end behavior. Okay, we are going to go back. If you still have Desmos handy, grab it. We're going to go back, and I want to do number 7. 7's this we're going to end with. So number 7 down here is x squared minus 1 over the square root of x squared minus 9. We're going to try putting that into our Desmos. I'm going to share my screen. Hopefully it's still around. Yes, it is. All right, so whenever you're doing a fraction, and I think we talked about this, whenever you're doing a fraction, you need to keep parentheses around your numerator and parentheses around your denominator. So you are plugging in, and you can see it on my screen, an x squared minus 1 on top, and a square root of x squared minus 9 on the bottom. Again, both in parentheses. Should give you this funky looking picture. You can see my screen. Now before you go and draw it on your paper, let me tell you some things about it. I'm going to give you a minute though to get it up on your Desmos, because we need to figure out some coordinates that are important to us. So if I'm looking at this, I want to know what these low point coordinates would be. So there's one here. It's at negative 4.12, let's say negative 4.1, and positive 5.7. That guy right there. And when I swing to the other side, oh wow, it's symmetric. It's got the same thing, but it's positive 4.12. 5.7. All right, those are important. So that's what you're going to do. You're going to grab those important points so that then you can answer the questions and graph your graph. So I'm going back to now my number 7. One thing I can tell you about this graph, and it was hard to see on Desmos, but at 3 and negative 3, there's asymptotes here. So 1, 2, 3, if I go over here, that was an asymptote, this guy's an asymptote. There's nothing happening between those. And it kind of makes sense because remember the coordinates we just found were at negative 4.1 and positive 4.1 on the other side of that. So it was at negative 4.1 and then 5.7, so almost all the way up to 6. 1, 2, 3, 4, 5, 6. So in this neighborhood, it came down and went whoop, off like that. And in this neighborhood, if I'd make the same coordinate over here, it came down and went off like this. That was the picture I got from Desmos. It didn't quite give you the asymptotes, but that's the deal. All right, so with that, I should be able to answer all the questions that we've got. Remember, these coordinates were negative 4.1 and 5.7. This guy here was positive 4.1 and positive 5.7. All right, have at it. Tell me what all those things are. I'm going to set you free, and then we'll see if we match. Okay, so let's see how you made out. So your domain went from negative infinity to negative 3, and then it hopped over to positive 3 to infinity. There's a gap in the middle between those two vertical asymptotes. So that's your domain. There is a minimum. The lowest point that it hits is this 5.7 number, but you could have put it as the coordinates. That's okay too. So either or. Negative 4.1, positive 5.7, positive 4.1, positive 5.7. So 5.7 is the absolute minimum for this guy. Nobody goes lower than that. Are there any locals? There's not, because there's nobody goes local and everybody goes high to infinity, so there's no local maximums or minimums. It is increasing, actually it's decreasing first from negative infinity to negative 4.1. And then increasing from 4.1 to 3, negative 3. And then it picks up again and decreases from positive 3 to 4.1, and then increases from 4.1 to infinity. So there's your increasing, decreasing situations. If I go far to the left, left, he goes up to infinity. Far to the right, he goes up to infinity. There's your left and right end behaviors. So, questions on Extrema? Okay, that leaves you with, tomorrow we're going to be talking the answers to these. So you need to have these turned in by tonight, midnight. It's only 4 questions now because we just did the other 3. So you're going to go back and do the other ones that we didn't do. The ones on the front page, they graphed for you already. So you're just looking at the graph and you can tell from the graph what the numbers are. The ones on the back side, you're going to have to use Desmos to get those graphs like we did today. And you're going to get those critical points, the points that, when you're looking at the picture, where's the lowest point, where's the highest point. So you're going to get those coordinates so that then you can answer all the questions they want you to answer about domains and range and maximums, minimums, and increasing, decreasing, and all that stuff. When we get together tomorrow, we're going to go over the answers to those, and then we're going to talk about roller coasters. So think about what your favorite roller coaster is. Ooh, right? I don't know. There's so many good ones. All right. If you are home, you can sign off. Again, you have numbers 1 through 7 due by midnight tonight. I will see you tomorrow. And for my kids that are here, you've got probably 5 or 6 minutes. You might be able to bang out a couple of them anyway. Okay?